4 years ago, the lives of these Turkish firefighters changed forever. An earthquake of catastrophic size tore their city apart.
Depremin üzerinden 72 saat geçmiş ve bu insanlar
Even after 72 hours of non-stop working, day and night, without any sleep, when we found someone alive, it gave us such a morale boost that we forgot everything.
şeyle başlıyorsunuz.
Although thousands died, many survivors owed their lives to the actions of these men and women.
İnsanlar çaresiz ve bu işleri yapacak
People were helpless, and as the fire brigade, we were the only ones they could turn to.
öyle zamanlar geldi ki
But there were times when even we felt helpless.
yani
I remember having to hide and cry secretly many times.
bir kenara çekilip ağladığım çok zamanlar oldu.
But now a frightening forecast suggests it is only a matter of time before these firefighters are needed again. Scientists have identified a new phenomenon called an earthquake storm, and one is blowing across Turkey. If their forecast is correct, then next in line is a city of 14 million people. On August the 17th, 1999, at just after 3 in the morning, a massive earthquake struck the Turkish city of Izmit. Thousands of people fled as their homes collapsed around them.
I couldn't fully understand what was going on. I didn't realize it was an earthquake as I wasn't fully awake. Mom was crying and she said, "Ömer, the house is going to collapse." And I replied, "Don't worry, Mom, just hold me tight." And that was the last conversation we ever had.
The earthquake claimed the lives of some 25,000 people. The destruction spread over hundreds of kilometers, and much of the area was reduced to rubble.
İnsanlar çok şaşkın bir vaziyette.
People were so shocked. Buildings had collapsed. Some of them survived, but some were still under the rubble. Some of them managed to get out of their home, and they just stood there, completely dumbfounded. They didn't know what to do and could not think of ways to help the trapped victims. Everyone was in shock.
Şoka girmiş bütün herkes.
Kadriye! Kadriye! Kadriye!
For the people of Izmit, the disaster was totally unexpected. But what they didn't know was that a year earlier the entire disaster had been forecast.
We made the calculations, we knew that Izmit was dangerous. Our work showed that this area was at risk, that an earthquake would come, and that tens of thousands of people were likely to die.
And yet that warning was not heeded. Few preparations were made. Few contingency plans were put into place.
When the Izmit earthquake happens, there were two sorts of feelings that sort of arose in me. One was frustration. The other one was anger. Anger with myself, anger with others, because sort of we knew it was coming. And yet nothing had been done.
Now, the same scientists who highlighted the threat facing Izmit have made another forecast. If they're right, the danger could be heading for another city. A city much bigger than Izmit. A city with over 14 million people. Istanbul. Because scientists believe that Turkey is in the middle of a new phenomenon, where one earthquake triggers another, and then another. Some are calling this an earthquake storm. The trail of clues that led to the discovery of the earthquake storm began here in Crete. "2,000 years ago, the Greek island was one of the key trading centers in the Mediterranean. But it was shattered when the island was apparently struck by the single biggest earthquake in recorded history. Evidence for that huge event is everywhere.
This line here, separating the light rock from the dark rock, is the ancient shoreline, and it carries on along this coast at the same level. And years ago, the sea would have been up here, lapping against the rocks here. And then something dramatic happened. One day, the land suddenly rose up by about 6 meters here, and the sea just dropped.
A drop of 6 meters is the mark of a truly great disaster.
The sudden jump of a coastline by this size really is a telltale signs of a massive earthquake.
Archaeological evidence showed just how devastating this one event apparently was.
With an earthquake of this size, it just crushes towns in seconds. When the earthquake starts to strike, the first few things, the walls start to go, the roof starts to come down, and anyone that's underneath is just crushed. What we're looking at here is crushed skeletons lying underneath masonry and roof tiles. And in amongst this all, we've got columns falling down, we've got pottery, we've got everything else. This is everyday life just crushed by an earthquake.
And amongst the remains lay a vital clue as to when the earthquake took place.
This particular coin is dated to Constantius II, and that puts it roughly about 360 AD. Now this coin was found in the skeletons of the people crushed under the ruins. And what that means is the earthquake destruction is dated to shortly after 360 AD.
Ancient writings provided more evidence for the disaster and dated it precisely to July 365 AD. And for centuries, many scholars found signs that the destruction from the 365 event had spread far wider than just Crete.
Terrible disasters took place all of a sudden throughout the world. For shortly after first light, preceded by heavy and repeated thunder and lightning, the whole stability of the earth was shaken.
As more historical evidence was discovered around the Mediterranean, more damage was attributed to this one huge event. Cities 1,500 kilometers apart appear to have been struck by the same earthquake.
A destructed Roman villa in Sicily, a destroyed Roman city in Libya, a destroyed Roman city in Cyprus, destroyed buildings in Alexandria. All of these have been put together to generate this just ginormous earthquake that struck the length and breadth of the Mediterranean.
It seemed that few places in the Mediterranean escaped its destruction. Its range was so enormous, this one earthquake became known as the universal event.
This was a truly giant earthquake. In fact, in terms of human history, this was the biggest earthquake the Mediterranean had ever seen.
But despite all the evidence for this one massive earthquake, there were some who had their doubts. It was just too big. Historian Emanuela Guidoboni has studied ancient earthquakes for decades and was troubled by the idea of this universal event.
The area of damage was enormous, but it just didn't add up because the damage area extended from Cyprus to Sicily, North Africa, Crete, reaching as far as southern Italy. It simply wasn't credible.
Intrigued, Emanuela re-examined some of the historical texts. She was drawn to one writing in particular. The scholar Libanius wrote an epitaph for the death of the Roman Emperor Julian the Apostate.
In this epitaph for Julian, he depicts these great images of earthquakes that shake the land and gives examples of Libya, Sicily, Greece.
Like a horse tossing its riders, she has destroyed a great number of cities, many in Palestine and all those in Libya. The greatest cities of Sicily lie in ruins, as does every city in Greece except one.
Many historians believe the epitaph referred to the 365 event, but Emanuela found something that didn't quite fit.
The dating of Libanius' text is fundamental for understanding the earthquake of 365. Libanius wrote the epitaph for Julian on the death of the emperor, that is in May 363.
In other words, Libanius had written his epitaph 2 years before the universal event. And there were other writings that didn't make sense. It seemed that other earthquakes had been misdated.
There had been 7 earthquakes before 365 and 3 afterwards. So in 12 years, there were 11 earthquakes, almost 1 earthquake a year. There was a seismic crisis in the Mediterranean.
For Emanuela, the theory that one single earthquake had wiped out most of the Mediterranean in 365 had to be wrong. There had been no universal event. Instead, it appeared that a cluster of separate earthquakes had exploded across the region in a storm, each event seemingly triggering the next. It was an ingenious idea. But the suggestion that one earthquake could set off another had always been regarded as scientific nonsense. Earthquakes are one of the most studied natural phenomena of all. In the last 100 years, they've claimed the lives of over 1 million people, and many more have been left homeless. Although extremely complex, scientists are beginning to understand what causes these events. They know that most earthquakes strike where the Earth's great continental plates push against each other at fault lines, like this. They also understand how they happen.
Well, this is an earthquake machine, and we know the Earth to be composed of 12 or so plates, and the plates are in constant motion, which is represented here by the winch, and along the boundaries of all of these plates are faults. And this is a fault where the sandpaper meets the brick in frictional contact. And the rubberiness of the Earth, represented by this elastic cord, stores the stress that builds up along the boundaries of these plates. And eventually, the stress overcomes the frictional resistance, and we have an earthquake.
But these faults stretch for thousands of kilometers. Pinpointing precisely where an earthquake will strike has always been a mystery.
We know there's going to be big earthquakes over time. We just don't know exactly when they're going to happen. They could happen 10 minutes from now. They could happen 10 years from now. There's just no way to predict it.
The one thing they did know was that smaller tremors called aftershocks always followed a main event. But finding a connection between large earthquakes years apart had proved impossible. Scientists had to accept that the planet's most destructive tremors struck randomly and were totally unpredictable.
Basically, I'm throwing darts at a map. And so the whole world of earthquakes was viewed as dart throws that were independent, in which nothing about the last earthquake was going to condition my ability to say very much about the next earthquake.
So the idea that earthquakes were random became the accepted view. The trouble was, the historical evidence suggested that large earthquakes were very much connected.
We're finding these earthquake clusters other times in human history. We've got them in the 18th century and the 15th century in Turkey. And people are even suggesting that the end of the Bronze Age civilization across the whole Mediterranean region could have been due to one big earthquake cluster. So the big question is that just random? Is that just chance? Or are we actually got a process where one is triggering the other, which is triggering the other?
The archaeological evidence was suggesting one thing, but the scientists just could not explain it. There was simply not enough evidence. To understand how earthquakes might interact, they needed far more data than the historical records could provide. There was one obvious place to look. The San Andreas Fault in California. One of the most active earthquake zones in the world, this great scar on the Earth's crust was created when one continental plate clashed with another. Seismologist Sue Hoff has been fascinated by this area all her life.
Well, I've been driving all over California looking for places like this, places where you can see evidence of faults in the ground. And what's remarkable about this place is that usually when plates slide past each other, the effect on the landscape is very subtle. And here you can stand not only in a fault zone, but actually on a plate boundary. And that's really remarkable. You can go a few steps over here and you run into the Pacific plate, and that continues all the way to Japan almost. A few steps in this direction and you run into the North American plate, which keeps going all the way to New York. So you have massive tectonic plates on either side, and this is the one place where they meet. And this is the place that great earthquakes are going to happen.
What makes the San Andreas so notorious is that sitting at one end is San Francisco Bay. The 6 million who live here know an earthquake could happen at any time. Famously, one struck the city in 1906, killing over 700 people. Another hit in 1989. This time, over 200 people lost their lives.
The earthquake hit at the start of San Francisco's rush hour, and on a key double-deck motorway in Oakland, a top tier collapsed, trapping hundreds of cars on the lower tier on a mile-long stretch.
With so many lives at stake, understanding how earthquakes behave along the fault is critical. This has made the San Andreas one of the most studied faults in the world, and along it there is one place more closely observed than anywhere else. Parkfield, the earthquake capital of America. Parkfield is wired with a huge network of high-tech equipment. John Langbine is one of those in charge of these sophisticated earthquake monitoring devices.
Here at Parkfield, we have a variety of different instrumentation, some of which include seismometers, which measure vertical and horizontal motion. This is a GPS unit. This is a 2-color EDM. This is a creep meter and across the hill, we have the deep drilling site.
And the reason Parkfield was the hub of earthquake activity in California was because it had suffered from earthquakes with unusual regularity.
The last one was in 1966, the prior one was in 34, and the one prior to that was in 22. But extending over a longer period of time, they appear to be roughly every 22 years.
On that basis, it meant that the next one was expected around 1988. By 1987, much of the equipment was in place and Parkfield was ready to capture an earthquake as it happened. Then the wait began. 1988 arrived. They waited and they waited, but the year passed without event. 1989, nothing happened. 1990, nothing happened. 1991, still nothing happened. Then in 1992, something did happen. California was hit by the most powerful earthquake in 40 years. The only trouble was, it wasn't at Parkfield. It was more than 400 kilometers away and struck the small town of Landers.
The small desert community of Landers was a pavement ripped and scattered like someone shuffled a deck of cards. Before today, few people probably had ever heard of Landers, California. Now, the community has made seismic history, the largest amount of ground movement in a California earthquake in over 100 years.
Geologist Sue Huff felt the tremors from 100 kilometers away.
The Landers quake, where I felt it, it was like somebody picked up my house all of a sudden and just started shaking it back and forth. The power in it is just remarkable. It comes out of nowhere, and the energy involved is just staggering.
One person died, and 171 people were injured. There was millions of dollars worth of damage. And the fact that Landers was hit and not Parkfield seemed to show just how unpredictable earthquakes could be. But Landers was not the dead end it first appeared. In fact, it was to give scientists their best insight into how one earthquake could set off another, and it would bring them closer to understanding the earthquake storm. Because 3 hours after Landers, a huge aftershock struck 40 kilometers away, near the town of Big Bear.
Holy shit!
This footage was taken at a nearby observatory as the earthquake hit.
What happened to the telescope? Destroyed. What do you go, come on! It may fall off! I got it on tape!
Convinced the two events were linked, geophysicist Ross Stein was determined to find the mechanism for how Landers had triggered Big Bear.
The argument of people who held that earthquakes were independent and random was basically to dismiss the presence of aftershocks. Just say, well, let's just skim those off the record of earthquakes, and what's left over is random. And that seemed ludicrous to me because about a third of the earthquakes in any earthquake catalog are aftershocks. But when I began to look, I saw that aftershocks were occurring all over the place, very, very far from the fault that ruptured. And so aftershocks were the clue that we needed to follow up, to figure out how earthquakes interacted.
And his team had a great opportunity. Instruments around the state captured Landers and the aftershocks that followed in extraordinary detail. The scientists knew how deep the rupture went, where the fault had broken, and precisely how far it had slipped. They had numbers for everything.
Data is king in earthquake science. It trumps theory, it trumps everything. When we have great data, we really can develop a deep understanding. Nothing exceeded or met the quality of data we had for Landers.
Never before had there been so much information about two earthquakes, so they set about looking for any connection between Landers and Big Bear. They had been working on a computer model that they hoped would illustrate how one earthquake could trigger another. The idea behind it was remarkably simple.
Go! Come on!
As an earthquake strikes and the fault lines pull apart, the system releases a huge amount of pent-up stress.
Move it! Come on!
Their theory was that as the earthquake releases this stress, it is redistributed to areas close by, seen here in red. These are the likely areas where the next earthquake should take place. The trick was to find out where these red zones might be. To do this, they began to feed the data into their computer. The model had to take into account hundreds of calculations about how much the fault had slipped, how deep underground the rupture had occurred, and the elasticity of the Earth's crust.
So the way we set this software up was to give us a visual sense in which areas were more likely to produce earthquakes and were more hazardous were turning red, and areas that were farther from failure were blue.
Finally, the model showed where the stress from landers had been transferred. The area to the west lit up in red.
We were hunting for the possibility that Big Bear occurred in a region, one of these red lobes, where the stress was jacked up by the occurrence of the Landers earthquake.
And sure enough, slap bang in the middle of the red zone sat the Big Bear earthquake.
Having Big Bear land in the middle of our red blob was very exciting. But that in itself doesn't clinch the case, because Big Bear could have landed there by accident, and that's always a possibility. And so what we were to depend on were not just that one earthquake, regardless of its size, but the 3,000 or 4,000 other aftershocks that occurred in the first few weeks. Were those also occurring in the red zones?
Once again, they returned to their model. They set about plotting every single aftershock that rippled out from the Landers quake. And just like Big Bear, most fell in the red zone.
We came away from this experience feeling that Landers had taken a possibility, a possible set of interactions, and turned it into a probability. It now looked to us like this kind of earthquake interaction was likely.
Landers was a scientific breakthrough. It gave the most dramatic evidence of how one big quake could trigger another.
The Landers was really a landmark event in giving us this incredible data set that showed us how different large earthquakes interact and letting us explore the mechanism of this interaction in detail.
It was the best example so far of how the transfer of stress could trigger a large aftershock. However, it did not show how one event could set off larger earthquakes across longer periods of time. It did not prove the existence of an earthquake storm. To show this, scientists had to test their model on somewhere even more dangerous than the San Andreas Fault. Turkey is in one of the major earthquake zones of the world. Here, millions of people live under the threat of one of the most treacherous faults on the planet. The North Anatolian Fault slices through the top of the country for over 1,000 kilometers. For centuries, earthquakes along this fault have torn the region apart. In the last 100 years alone, it has claimed the lives of nearly 100,000 people. Seismologist Jalal Şengör knows it as well as any.
The North Anatolian Fault seems to display a cyclic behavior. It looks as if Earthquakes start at the east, they migrate west, then there's a period of quiescence. It starts again, migrates west, there's another period of quiescence.
This pattern, heading from east to west, attracted earthquake hunters from around the world. Among them was Jeff King. He became fascinated by a study of the fault that suggested these earthquakes might be triggering each other. This study began with an event that happened over 60 years ago. In 1939, a devastating earthquake struck the city of Erzincan in eastern Turkey.
The earthquake that occurred in Erzincan in 1939 was the start of a sequence of earthquakes that passed right along the North Anatolian Fault. It was a major event that killed tens of thousands of people.
Though there was very little data from the event, there was enough to make an educated guess as to where the stress had gone. Using the same model that had shown the Big Bear and Landers connection, the red zone produced from Erzincan lit up an area to the west. Tragically, 3 years later, in 1942, an earthquake struck near the town of Tokat. The model seemed to be working.
After the Tokat earthquake, stress was transferred to the west. The next earthquake was to the west.
Then a series of earthquakes struck westward along the fault, the last in 1967 near Adapazarı. The model showed that each event had occurred right in the middle of the red zone. The earthquakes seemed to be triggering each other like a set of falling dominoes.
Following the Erzincan earthquake, a series of events zipped, or rather unzipped, the fault right the way along its length, with stress being transmitted from one to the next in a most spectacular fashion.
These events were not aftershocks, and they were separated from each other by years. An earthquake storm appeared to be blowing across the region. But forecasting earthquakes after the event was relatively simple. A better test would be for scientists to use the model to forecast where the storm would strike next.
Our objective was to go from the 1967 earthquake to the west and to the south, and include all the other earthquakes for which we had historical information in order to assess where stress had been transferred and what was the likely earthquake future for those regions.
And when he plugged in the data, the red zone lit up over the Bay of Izmit. Home to nearly 500,000 people.
The red zone was right over Izmit and the Bay of Izmit, and we knew a major fault capable of catastrophic earthquakes passed right through that region.
Jeff and other scientists were so convinced the model was working, papers were published forecasting where the next earthquake would likely strike. They could not say when, but they spelled out the specific threat to Izmit.
A catastrophic earthquake seemed to us inevitable, and this had to be published.
This was published in the scientific literature, but then it was also published in the Turkish popular press, the popular scientific journals, even in a newspaper, in the scientific supplement of a newspaper. I must confess, even when I read that, I said, oh, wonderful, it's a scientific prediction. But it did not occur to me to say, my God, we've got to do something about it.
The publication created only a ripple of interest, and for the people of Izmit, life continued as normal. Most had no idea that the ground they now walked on was under extraordinary stress. Then, in August 1999, at just past 3 in the morning, Jeff King's forecast came true. "45 seconds later, much of the city and the surrounding area lay in ruins. The quake was so huge that buildings collapsed nearly 100 kilometers away. Despite the warnings, the area was totally unprepared. Fire Chief Emin Pehlivan and his team were just not ready.
O günkü şartlarda da
I could say me and my team, we did our best under those circumstances. And I am proud of that.
İmkanlar dahilinde çok şeyler yaptık.
We did a lot. We stretched resources to the limit. But this disaster caught Turkey off guard.
The rescue services had been given neither the equipment nor the manpower to deal with the disaster.
Ölü şahısların çıkartılması esnasında veya
When we pulled out dead bodies or heard about them, it was equally devastating. There were times, most of the time, we pulled out more corpses than survivors and felt completely broken down.
durumumuz söz konusu olduğu için çoğu zaman moralman çöküyor idik. Bir telsizde mesela duyuyordum.
Each time we heard through the wireless that someone had been pulled out alive, a man, a woman, age this or that, we felt wonderful.
Bizim buradaki en azından karargahta olan arkadaşlarla beraber
All of us in the headquarters shouted out of joy as if we had won a victory and hugged each other.
çığlık atıyorduk yani resmen birbirimize sarılarak çığlık atıyorduk.
Ya şuradan bağırıyorlar.
Among those trapped was Ömür Kunay. She and her mother had been caught in one of the many collapsed buildings.
İçlerinden tanıdık sesleri ayırt etmeye çalıştım.
I tried to make out the voices I knew. I heard babies crying. I was lying on top of my mother. I was trying to hold her hand, talk to her, but she didn't respond.
This is the very moment of her rescue. She was finally found nearly 3 hours after the fault had ruptured. But her ordeal was far from over.
Ben orada ses verdim.
I warned them when they were digging close to my head. Then they dug the area below. I could move my left hand. I managed to get it out through a hole, and they dug around it. They removed the concrete with the crane, removed my mother. My hair was still under the rubble. The man started crying. He said, "We can't get you out, my child. Your hair is trapped." I said, "Cut it." He kept crying and said, "I can't cut this beautiful hair."
Ömür was rushed to hospital, knowing nothing of her mother's fate. Her visiting family kept any news from her.
Annemi kaybettiğimi
I learned about the loss of my mother after about 40 days. My family couldn't bring themselves to tell me. My aunt was with me. She was the one looking after me. One day I said, "I asked you to take my mom's photo. You didn't even bring me a photo." She started crying. My cousin left the room, and I realized Mom was dead.
The exact number of casualties from the Izmit earthquake is still not known. But some estimates suggest that perhaps 25,000 people died. Hundreds of bodies are still unaccounted for.
Bir dakika baba yapma gözünü.
But for Jeff King, one of the scientists who had made the forecast, the Izmit earthquake was a bittersweet moment. He had been proved correct, but he now realized that use of the model came with enormous responsibility.
As the scale of the disaster became clear, we were clearly right in our prediction. But this was on the one hand, you want as a scientist to be right, but on the other hand, you hope you're not right, because you realize that the red areas that you calculate represent many deaths, tens of thousands of potential deaths.
Now it really did seem that an earthquake storm was heading across Turkey. It was vital to forecast where it would hit next.
Well, after the Izmit earthquake, we had important new data. I mean, we could immediately expand the studies that we were engaged in to see what would happen next and what was likely to happen next. So, following the earthquake, we immediately accelerated our work in this area.
Jeff King and his team set to work to try and find where the stress had moved. As they put the new data from the Izmit quake into the computer, an area to the west again beamed red. This time, though, things were not so straightforward. Izmit had been forecast because scientists knew the exact nature of the fault running through the area. But now they could not tell.
The fault that moved in the Izmit disaster passes under this road. It then, at this point, it goes offshore, under the Marmara Sea, and completely disappears.
The extent of any danger in this newly stressed red zone depended on understanding the exact nature of the fault.
Before the 1999 Izmit earthquake happened, we knew very little about the Sea of Marmara. The North Anatolian fault, we know that enters at one end, exits at the other. But in between, we really didn't know much more.
What made this all the more urgent was the fact that when they ran the computer model, at the edge of their newly plotted red zone was one of the greatest cities in the world. Istanbul. With so much at stake, it was crucial to understand the fault in intimate detail. Just how big a threat was there to the city? Soon the Italians, French, Turks and Americans set about making the fault at the bottom of the Marmara Sea one of the best known on the planet.
The first thing we thought we had to do was to map the sea, to know where are the different features on the bottom. Because in a sea, the erosion is not active like on land, so you preserve the trace of faulting in a much better way.
Gradually, the fault began to reveal its secrets. Mud cores taken from the sea floor revealed the huge quakes that had struck the area in the past. And seismic signals indicated that the whole area was still very much alive. Other results showed just how vast the faulting system was.
We found this long valley that cuts through the whole two-thirds, the western two-thirds of the Marmara Sea, a spectacular valley that we did not expect, and that was obviously a very active fault.
Although a picture of the fault's activity was emerging, the exact structure of the fault remains unclear. But what was known was that an active faulting system stretching nearly the length of the Marmara Sea sat a mere 20 kilometers from Istanbul. A big rupture along this fault, whatever its precise nature, could be a massive disaster.
The earthquake that we expect will happen close to Istanbul will be as big or bigger than Izmit. Izmit killed 20 or even 30,000 people. The population density around Istanbul is 10 times greater. The scale of the catastrophe to a European city is almost unimaginable.
What makes this forecast so worrying is that many buildings have not been built to withstand a disaster of this kind.
We are now in one of the poorest parts of Istanbul. You can imagine that the buildings around us are not of the best quality. When the earthquake hits, parts of these buildings will fall down. People will be trapped in them. Some of the people will be able to get out. Some of these streets have natural gas pipelines going under them. They will burst, right? You'll have fires rising. People will try to run away. They'll be ruined. They will try to clamber up. Rescue units will try to reach them. It'll be complete mayhem in Istanbul if that happens.
No one can yet tell when the earthquake storm will strike. The forecast simply cannot do this. It could be in 100 years' time. It could be tomorrow. But scientists have at least identified where it is likely to hit next. This means there is still time to prepare.
Stress has been building up in Istanbul. We know there's going to be an earthquake. We don't really know when there's going to be an earthquake, but we know it'll be a major earthquake. Buildings can be improved. Construction can be modified. Emergency services can become better organised. There are very many things that can be done, and this will bring the death toll down by 10 times or even 100 times. And it is completely possible, and it is economically feasible.
So the forecast comes with hope. There is a chance this time that the people of Turkey can be prepared when the disaster strikes.